Hi, I am Maqsudur Rahman. This is my video submission for the sensor calibration assembly assessment Millis flying fish. Here is my model frame with the MPU attached in this orientation. Underneath the fish, I have put a printed paper with the degrees. So I have a to this is because to visually verify the sensor position against our program output. The aim of this uh, experiment is to get sure that the calibrated MPU is actually working correctly, precisely. And the way the systems work is that when we power the board, the Arduino, the setup function runs our custom calibration loop in the code. It takes 500 stationary readings from the MPU gyro along the x-axis to calculate the static offset bias. The reason we're just using the x-axis because the way my MPU is mounted here, so when we are moving it sideways like this, so it's just moving along the x-axis, so we had to cancel out the z-plane and the y-plane readings. And here is a code, and the system code about it's an offset of about 2.34 degrees, so it's subtract the offset bias from the readings and kind of give us accurate measurement and set our baseline for 0 when it's in stationary. So let's now see if this is actually making correctly, working correctly. So right now we are at 0, and here you can see the fish angle is 0.24 degree, and let's try move it with I would say positive 30 degree like this. I'm gonna hold it with my hand because the cable is pulling the fish towards it. Okay, so oh yeah, and here you can see 29 30 degrees, so it's working. And let's try some other angles, maybe 15 degree, minus 15 degree in that way. Yeah, and here you can see it's 14, close to 15. It's because I'm holding with my hand. I can't hold it very stationary, so it's fluctuating. So I'm gonna try another angle. Let's go for maybe 90. Yeah, and let's see. Yeah, it's 91, 90. So we can say that it's pretty accurate. And now I would like to talk about the drift and limitation of this. Here, if you can clearly see that the Millis fish is currently at a stationary position at 20 degree, and by the readings you can see that the even it is in stationary, the readings are kind of increasing slowly from 64 to 65, then 66. This is because of drift, and the gyroscope angles are computed via numerical integration multiply angular velocity by change in time. Because small electrical noise accumulates over time, pure gyro integration will experience slight long-term drift, usually or normally, In this program, I have added a dead zone noise threshold in software to minimize the drift when stationary, making short-term dynamic response highly accurate for control system. For long-term absolute stability, combining this with a accelerometer via a complementary filter would be the next step, I would say. And as you can see, it's already 73, and it's rising. So yeah, that's it.